How do engineers handle ethics when bridges fail? When a bridge collapses, it raises serious questions about the ethics of engineering practices. How do engineers navigate these challenges? Let's break it down. Engineers have a responsibility to prioritize public safety above all else. This means they must act decisively when they notice signs of structural issues. For example, if there are cracks or unusual deformations, engineers cannot ignore these warning signs. They must take action, even if it means halting construction or closing the bridge to traffic. Ethical engineers are vigilant in recognizing and reporting problems. They pay attention to concerns raised by workers or inspectors. In some cases, these voices have been ignored, leading to tragic outcomes. Ethical practice requires that engineers listen to all sources of information and investigate thoroughly. Another key aspect is independent review and peer checks. Engineers must allow their designs and construction decisions to undergo scrutiny by external experts. Refusing to do so can lead to unchecked errors. A historical example is the Quebec Bridge collapse, where the chief engineer rejected independent checks, resulting in fatal design flaws. Transparency and accountability are also vital. After a failure, engineers must participate in open investigations. They need to share their findings honestly. Sealing investigation records or hiding information only hinders progress. Transparency helps the engineering community learn from failures and improve future designs. Admitting errors is an essential part of ethical engineering. Engineers must acknowledge their mistakes rather than conceal them. This includes taking responsibility for design or construction errors and working to correct them. Concealing mistakes can lead to repeated failures and erode public trust. Continuous learning is crucial for engineers. They study failure case studies to improve their knowledge and experience. For instance, the Tacoma Narrows Bridge collapse taught engineers about the importance of wind tunnel testing. Ethical engineers integrate these lessons to avoid repeating past mistakes. Finally, engineers must protect public safety above all else. Even when faced with pressure from clients or contractors, safety must come first. This may mean recommending bridge closures if there are doubts about structural integrity, regardless of the inconvenience it may cause. In practical terms, ethical engineering means conducting thorough inspections and monitoring during and after construction. It involves creating a culture where all team members can report safety concerns without fear. Engineers must ensure designs are based on sound knowledge and support independent reviews. Sharing failure data openly for research and education is also important. Ethical engineering transforms failures into opportunities for learning. It helps ensure that bridges and infrastructure are safer and more reliable in the future. By handling ethics responsibly, engineers contribute to a better understanding of structural integrity and public safety.